guys, and welcome to today's video on adding and subtracting fractions with different denominators. If you haven't already watched my video on adding and subtracting fractions with the same denominator, I'd recommend doing that first and then come back and watch this video because it jumps off some of the same concepts. Okay, before we go too far, I want to recap something that I've talked about before. It's a little trick that I use with some of my students to help them remember whether or not we need to find the same denominator to be able to carry out an operation with fractions. So if you see a problem with fractions that is asking you to either add or subtract a fraction, those two go together. They're the inverse of each other. So they're a pair. And you remember that S for subtract means S for same. They need the same denominator. And in the same way, multiply and divide go together because they're the inverse of each other. And there's a D in divide, which means we can have different denominators when we're working with multiplication and division of fractions. So addition and subtraction, which is what this slideshow is about, for those operations, to have the same denominator. Now, that doesn't always happen when we first get given the problem. If you look at my other slideshow, sometimes we do get given questions where the denominator is already the same. And then that's easy to compare because it's like adding pieces out of one part of a number, in adding those two pieces of the same size from another part, and then seeing how much we have all together. But what happens when the pieces are not the same size like we see on this slide here? For the question 3/5 plus 5/8, you can see that when I break my piece, my whole circle, which happens to be the same size for both, but when I break it into 5 pieces, 1, 2, 3, 4, 5, each of those pieces is a little bit bigger than when I break that same size whole into 8 pieces. Those 8 pieces are slightly smaller. So it's very difficult for me to compare if I add these pieces to these pieces to see how much of a whole number I have. And that is why it's really important for us to find a number that we can split both of those whole parts into so that we can add them or subtract them without having to worry about that. So what we want to do is find a way to break both shapes into the same number of pieces, so then we can work out how much we have overall once we either add these bits here together, or we might take away part of a number. And I've just shown here in the green how you could sit there and work out how to break the numbers up by hand using a diagram like this as a visual representation. But you can also, and I don't know what's happened to my floor here, but you can also just simply use maths to work this out. So let's have a look. How do we know how many pieces to break these numbers into? One of the easiest ways to do this is to use the denominators, which is the number on the bottom of each of the fractions, the denominator. The number up the top is called the numerator, but right now we're looking at the denominator. That's the number that the whole is broken into, how many parts we have in the whole. So this number is 3/5. The 5 is the number of parts I've broken that into, and the 3 is how many parts are coloured. The 8 is how many parts this one's broken into, and the 5 is how many parts are coloured. So what we can do is multiply those two denominators by each other, and that will give us a number that both of them go into. If I multiply 5 by 8, then I know 5 is going to be one of the factors of that answer because I've multiplied it by 5, and also 8 is going to be one of the factors, which helps us to work out what these fractions would be with that same denominator. So here I'm going to break each of my 5 into 8 little pieces. So 8, 8, 8, 8, and 8. That's kind of what I'm doing. And remember, I get the 8 because the other number is broken into 8. And so I'm multiplying these two together. So I'm getting, for each of these 5, I'm multiplying it by 8. So 8 plus 8 plus 8 plus 8 plus 8, 5 lots of 8. And over here, I'm going to use the denominator from the other number, and that's 5. So I'm going to make each of these into 5. 5 plus 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 5, or 8 times 5. So I've got 8 lots of 5 and 5 lots of 8. So what does that make our new denominator? Well, 5 times 8 pieces and 8 times 5, remembering that these are the reverse or the turnaround of the same number fact, and they give us 40. So when I have each of my 5s broken into 8 pieces, I have 40 pieces in total. And when I break each of my 8s into 5 pieces, I have 40 pieces in total. And now we have the same denominator. Once we've worked out the denominator, we have to go back and put in the numerators. So let's go back to that first fraction that we had, 3/5. Now my new denominator is going to be 40, so I need to work out what my new numerator will be. To find that 40, I did 5 and I multiplied it by 8 to get 40. There's a little rule for fractions which you'll probably know that whatever you do to the bottom, you have to do to the top. So if I have multiplied the bottom by 8 to get to 40, I'm going to multiply the top, my numerator, by 8 as well to get my new numerator. Now, if you remember back to when I had the numbers around my shape and I had numbered all these segments, I said this was going to be 8, 8, 8 for each one. So 8, 16, 24, which makes sense because it matches the fraction that I have over here. So when I break my pie or my whole number or my pizza or however you want to think about it, when I break it into 40 pieces, I'm still going to be colouring in or taking the same proportion out of the whole number. But when I do that, this part, instead of being 3 pieces out of 5, it's going to be 24 pieces out of my much smaller pieces of 40 of them. So I'm breaking all these into much smaller pieces now to get 40 little pieces out of the same whole, and these are going to be 24 of them. And that's called an equivalent fraction. In other words, the number at the bottom is changed, the amount of pieces that I'm breaking it into, but what they represent is still the same. The number at the top has changed, but what it represents is still the same. If I gave you this pizza on a tray and I broke it into 5 pieces and I gave you these 3 slices, the amount of pizza you'd get is the amount out of the whole there that you see. If I cut this pizza into 40 pieces and then I gave you 24 pieces, I'd still be giving you this big amount here that's shaded. You'd have the exact same amount of pizza to eat. It wouldn't matter how many pieces I broke it into, as long as I kept the number on the top the same proportion. So as long as if I break it into 8 times smaller pieces, I have to give you 8 times as many to make sure you get the same amount overall. And that's what we call equivalent fractions. So remember we had 2 fractions that we started with. The first one was that 3/5, but the second one was 5/8. And here's that picture. So what are we going to do to the numerator here? Well, remember, I multiplied my denominator by 5, and the rule for fractions, whatever we do to the bottom, we have to do to the top. So we're going to multiply the top by 5 as well. And I remember that when I was making this slideshow, I think I made a typo. I did. I fixed it on here, but it's not very neat. But 5 times 5 is 25. So the equivalent fraction here for 5/8 is 25 over 40. Now, I've got my denominator, and once I've made it the same, I don't have to change it again. My answer is still going to be the same denominator, but my numerators I have to add together. This is where the adding up takes place. So if I add 24 and I add 25 together, I get 49 out of 40. So in other words, I've got a whole pizza full of 40 slices, and I'm going to have some slices left over, aren't I? I'm going to have 9 slices left over. I can't simplify this bit here, so I'm going to leave it as 1 and 9/40. Now, what about if I changed it to a subtraction? So instead of having the addition in the middle, I'm going to turn it into a subtraction. Same thing. I'm going to use that same denominator, but I'm going to imagine that this time around when I changed my numerators, I had 24 over 40 and I had a different fraction that became 15 over 40. I'd take away and do the subtraction at the top, 24 take away 15, which would give me 9/40. So the trickiest part of adding and subtracting fractions is getting that denominator to be the same. Once we have it the same, the adding and subtracting part with the numerators is not too difficult. So remember, the easiest way to find that same denominator is simply to multiply together the denominators of the original number. And remember, if you do that on one side, you have to multiply both the denominator and the numerator by the same number, and the same on the other side. When you're changing this one to the common denominator or the same denominator, make sure that you do the same to the bottom and the top of the fraction. I hope that was helpful. If you need more help, please comment on this video or email me to jane@lavenderlearning.com.au. Don't forget to like the videos that come up on this channel, subscribe to the channel and hit the bell so that you get notified when other videos come up too. If there's a topic you're really keen to hear more about, please send me an email or pop that in the comments as well, and I'll do my best to provide that advice and help in another video. Thanks guys. Bye.